Okay, so here is our second scalar versus vector. Speed is our scalar, velocity is our vector. Now, the big difference between speed and velocity is that speed is total distance traveled divided by time, whereas velocity is looking at the overall start compared to stopping point divided by time. Okay? While it seems similar, it can be drastically different, just like you might have learned with the last video about displacement compared to distance. So we're going to do a practice problem. Before we get into this, here comes your second mystery word. It's milk. Milk. Not chocolate milk or whole milk, just milk. The word. All right. So basically, we're going to work through this problem because vector changes get a little bit trickier when you actually have to start calculating for something based around a graph. Whereas before, you could just kind of look at the graph and be like, well, I started here at 0, ended here at 0, bam, I got my displacement. Or I started here at 0, I ended here at 60, bam, I got my displacement. Maybe I might have taken all these different paths to get there, but displacement only cares about one thing and one thing only. Start compared to stop. Vector changes with velocity. While it is the same, it compares start compared to stop. This is where most kids start messing up a lot with vectors compared to scalars. So let's work through this. If I wanted to calculate the slope of this section right here, all I gotta do is rise over run. So I run 3 seconds, rise 6 meters, and I get my value of 2 meters per second. If I look at this section, what's my slope? Oh my God, it's 0. Did I hear that from someone in the back? You're right, it is 0 meters per second. And then down here, again, I move 6 meters in 3 seconds. But, slight trick to this problem. Am I going in a positive direction anymore? Am I walking away from this starting position? Or am I walking back towards it? Oh my God, I think I heard that again. Someone in the front this time, thank you. It is negative 2 meters per second. Because it is 6 divided by 3 is still 2. But since I'm going down, the rise isn't in a positive, it's actually in a negative. Now, there are 2 ways we can go about doing vector addition / subtraction. Easy thing is, like I was saying before, look at the overall displacement. I started at 0, ended at 0. So my ending point, 0, minus starting point, 0, divided by, we'll say 9 right here, just because 9 is just a funky number compared to 10. So my total average velocity for this problem is 0 meters per second. But if I were to look at my total distance covered, we know it's 12, right? Because I walked 6 meters forward, 6 meters back. So 12 meters. Now, if I do the same thing where I'm looking at that 9 seconds, divide by 9, we get a value of 4/3 meters per second. You see how this can be drastically different, even though it looks the same, and the only thing that's changing is a word? My average speed is 4/3, but my average velocity is 0. That tends to happen with these problems where if there is a change in direction, your average speed will probably be a little bit greater than your average velocity. Other way of doing it is you can add up all the different velocities of the different sections. So you can do 2 plus 0 minus 2, and you get your same answer. Okay. Go to the next problem. Do the math.